American farmers are baling nearly 50 million tons of hay a year. Twine to bale this and other profitable crops is one of the most essential of farm supplies. Twine by the millions of miles. Twine available when and where the farmer needs it. Quality twine the farmer can rely on. Where does this vast supply of twine come from? To begin with, harvest twines, rope, and other hard fiber cordage products are made from one of three basic vegetable fibers: abaca, Cisalana, and henequen. Of the millions of varieties of plants grown throughout the world, the fibers from these three are best suited for cordage purposes. But because of climate and soil conditions, none of them can be grown in this country. The abaca plant, which produces a fiber commonly known as manila and is used primarily for making rope, comes from the Philippines and Central America. Here's a plantation in the Philippines. Some plantations are large, like this one, but more are small family farms. The mature plants, which closely resemble the banana tree, are first cut down. Then the unusable tops and bottoms are lopped off the stalk and discarded. Next comes an operation called tuxing, which is a good deal more complicated than it looks. Individual layers are carefully stripped from the stalk by an experienced farmhand who knows just how and where to cut. Each layer contains only a few of the strong, tough manila fibers, but they're the finest natural fibers found anywhere in the world for rope making. The tuxies are made up into bundles of 100 and hauled to the stripping shed. Here, the operator winds the tuxies around a spindle and pulls them over a serrated knife. This scrapes off the pulpy waste material, which is more than 90% of the tuxie, and leaves the prized abaca fibers long, strong, and ready for curing. After a day in the sun, the fiber is carried by that standard Philippine conveyance, the water buffalo cart, or sometimes by more modern means to warehouses in nearby seaports for weighing, grading, and storage to await shipment to the United States. The other two cordage fibers, Cisalana and henequen, are generally similar in appearance. However, Cisalana fibers are longer, stronger, smoother, and make up into more uniform, trouble-free twine than henequen. Since it is more economical than manila for the farmer, the U.S. cordage industry uses Cisalana exclusively for baler twine. Henequen, weakest of the three fibers, is used in making binder twine where not so much strength is needed. Cisalana is grown in the tropics, Africa, Haiti, Brazil, and other parts of Latin America. Henequen is grown in Mexico and Cuba. The tremendous demand for twine requires large plantations and processing plants. Locations are selected for the quality of the soil, loose, rich in lime, naturally fertile. Planting is all handwork with a grub hoe. That's something we don't see on our mechanized farms. But different crops require different methods. The young plants are suckers cut from the roots of mature Cisalana plants. Embedded in holes about 6 inches deep, the suckers will use their first year to send long roots into the rich loam. After a year and a half, their leaf growth has started, and the plants, a variety of cactus, look larger and healthier. After 2.5 years, the plants are ready for harvesting. 2.5 years. By our farm standards, that's a long time to wait for a cash crop. Workers with razor-sharp knives harvest the mature lower leaves, leaving the newer upper leaves on the plant to ripen. Cutting just the prime ripe leaves is the only way to get the high-grade Cisalana that U.S. cordage mills will accept. And now the Cisalana farmer, like the American grain farmer, sends his product off to the processing plant. From the sidings to the main line, to join the harvest from other parts of the plantation. At the plant, the The bundles are untied and spread evenly onto a conveyor belt to be fed into the decorticator. Here is one type of decorticator, a complex machine for recovering the fibers from the leaves, or rather for removing the useless parts of the leaves from the fibers. The decorticator works by first mashing and peeling off the rubbery outer skin, then crushing the pulp into a loose, soft mass and scraping it away. Inside the machine, huge streams of water wash away the loose pulp, leaving clean, washed fiber, strong, smooth, pliable. It may have looked simple, but it took years of research and a good deal of money to design machines and train operators to produce this clean, quality fiber. As with tobacco, twine fibers must be cured before shipping. A day in the hot tropical sun will dry and bleach the fiber from pale green to white. After just the right amount of drying, the fiber is baled and sent to waiting cargo vessels for shipment to the United States. Then to an American cordage mill by rail or truck. Here, inspection begins all over again. Although that fiber was all classified before it left the tropics, it must be re-inspected and graded by U.S. cordage inspectors before any of it will be accepted for manufacture. It may all look the same to us, but these men have had years of experience in this business. They know fiber. They know the best fiber only will make top quality twine. This inspection is the first of a series of quality control operations rigidly followed in U.S. mills. Twine manufacture begins with the selection, preparation, and blending of the raw materials. For binder twine, henequen is adequate. But for baler twine, only 100% strong, tough sisalana is used. The raw fibers are spread evenly on a conveyor belt and sprayed with an oil and chemical emulsion to lubricate the fibers, to make them more pliable, and to make the finished twine mildew, rodent, and rot resistant. Important considerations to twine in the field and in the barn. The stream of treated fiber is passed between corrugated rollers to distribute the emulsion evenly. Manufacturing quality control begins right here. To make twine of uniform diameter throughout, the fiber must be fed to the breaker at a uniform rate, controlled by weighing it as it is carried into the machine. Pins on the right, moving faster than those on the left, begin to comb out the fiber and stagger the ends. The result is a uniform, continuous ribbon of fiber known as a sliver. But one combing isn't enough. The sliver will be combed and recombed, each time becoming smoother, glossier, more uniform. Each time the sliver goes through a breaker, it is blended and combed with other slivers. This is part of the unique American method of preparation to guarantee that every foot of finished twine will possess identical properties, uniformity, high tensile strength, and greater length, all necessary to economical baling. Again, each manufacturing step is checked by quality control. An inspector selects slivers from each machine at random. 100 feet are measured out and weighed to test for uniformity.